So if I take the first thing, so there's steps to division. Number one, find the zero of the divisor. So in other words, the thing is being divided by, right? We're dividing by x plus 1, right? So to find the zero of that, in other words, is mathematical talk for set this equal to 0 and solve for x. Does that make sense? So what number inputted for x would make this 0? -1. So that's where we start. We're going to start with -1. Okay? Everybody follow me so far? Number 2, set up the problem. But step 1 is very important. Step 1 is very important. But step 2 and step 3 are super. So here's what we do. Instead of writing out the long division like we did, we start by putting your 0 first. And then take all the coefficients off your numbers. So in this case, 1, 3, 3, 1. Everybody's following what I'm doing. All I'm doing is taking the coefficients straight from my polynomial that I'm divided by. 3, you're going to multiply, then add. Multiply, actually say break down and multiply and add. So here's what happens. You'll take your 1 and you're going to bring that down. That's going to give you 1. Everybody follow me so far? Then you're going to multiply -1 by 1. And that's going to give you, but that's going to give you -1, correct? Everybody follow me so far? Then you add straight down. That's going to give you an answer of 2. And then you're going to multiply -1 times 2, which gives you -2. Then you're going to add straight down, which is going to give you +1. Then you're going to multiply by -1, which is going to give you -1. Then you're going to add straight down, which is going to give you 0. If there was a number here, this would be your remainder. Everybody follow me so far? So then, since we started with x cubed, this first term has to be 1 degree less than that. So this is 1x what? Squared plus 2x, because it's in descending order, plus 1. Questions? Isn't this what we got in the very first problem? But this is way quicker. And you'll be able to breeze through some of these. All right, so let's do another one. Let's say we do, so number one says we have f of x is equal to 4x cubed minus 13x squared plus 15x minus 6. And we're going to divide that by the question says it's divided by x minus 2. All right, I'm going to leave this up that I have right here. Before I give you the answer, I'm going to give you a minute, literally 60 seconds, and see if you can come up with is there a remainder and what is that remainder? All right, let's see how quickly we can do this. So what's the first thing that I should do first? Find the zero, so that's gonna be 2, correct?
Right.
So then I'm gonna set it up 2, and then we're gonna walk it through. 4, negative 13, 15, negative 6. So first thing we're gonna do, bring that 2 down, bring that 4 down. 4 times 2 is 8. Bring that down. 8 times, let's see, 8 plus 13 is negative 5. Times 2 is negative 10. Then, you know, with positive 5, 10, 4. So if I was to rewrite this problem, it would be 4x squared minus 5x plus 5 plus 4 over x minus 2. In other words, you take your remainder and you're going to divide it by your divisor. So that makes sense at the very end. Yes.
Is that a 13 or 5? I think it's with an X.
13.
The 13.
It's
Fine.
Now, I noted earlier that x plus 1 was a factor of this one. And it's a factor if the remainder is 0. Now, that is the case because, let's look back at the very first problem we did. If I did x squared plus 2x plus 1, right? And I multiply it by x plus 1, I get back this x cubed plus 3x squared plus 3x plus 1. Does that make sense? And I don't have to have any extra things like any extra multiplication or modification to get back here. Does that make sense? However, is this a factor? Well, no, because I don't have something like that. I got to deal with this rational function. Does that make sense? So it's a factor if the remainder is just 0. In other words, when we say zeros of a polynomial, or we say factors of a polynomial, those are kind of like those are not the same thing, but they're kind of mean the same thing. In other words, in this case, we can say that x plus 1 is a factor of 0 because negative 1 is a 0 of this polynomial. Whereas x plus 1 is a factor of this polynomial here because negative 1 is a 0 of the polynomial. We're going to do some more examples. All right, let's look at number 2. Number 2 is equal to negative 5. Oh, wait, never mind. X is 5. So 28 plus x to the 12th minus x to the 5th plus 4x. Now, there is a theorem, basically, remainder theorem, that says the remainder and, oh, by the way, we're dividing by x plus 1. There's a theorem that says the remainder is equal to the value of that function. I'll give you an example. Let's say you have the function, I don't know, x cubed plus 2x plus 6, okay? And I want to figure out what f of negative 1 is. Well, you don't have to write it down, I'm just giving you some example. You put negative 1 cubed plus 2 times negative 1 plus 6, correct? And then this will give you negative 1 minus 2 plus 6, which will give you positive 3. Everybody cool with that, right? Well, instead, you could do is you could use synthetic division. You take negative 1 and you're gonna go 1, 0, 2, 6. Anybody know why I put the 0 here? Looking at this function? There's no x squared.
There's no x squared.
Correct, there's no x squared term. So whenever you're doing synthetic division, be very, 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 very careful to make sure that if there are any terms that are skipped, like x squared or x the fourth or something that's skipped, you use that 0 as a placeholder. So if I did this, it would be, let's see, 1, -1, -1, 1, 3, -3, 3. Oh, would you look at that? The remainder and the value of my function might be the exact same. Does that make sense? Y'all see how that's the same thing? So check this out. If I'm asked for the remainder, do I really need to divide this function by x plus 1? Not really. All I need to do is find f of the 0, which is -1. Y'all see that? All I need to find is find f of the 0 of my divisor. Which I can just do is we can -5 to -1 to 28 plus -1 to 12 minus -1 to the 5th plus 4 times -1. And so let's see, this is going to be -5. That's going to be +1 plus +1, because once again, this is even, right? And then you have -1, so it's going to be +1 again, and then -4. That should give me -7. Did I get my math right? So you can see that if I evaluate the function, it's the same thing as getting the remainder when divided. Suppose you said something like f of x is equal to x to the 4th minus 5, the 5x squared plus 6, I don't know. Okay. And let's say that I wanted to figure out the remainder if divided by x plus 2. Okay? Now, follow me so far. There's 2 ways you can do it. The first way is you can do synthetic division. The second way is that you can just plug in. So the first thing, either way, you're going to have to find the 0. So what would be the 0 of the divisor? -2. Everybody cool with that? So I'm going to show you both ways. So you do f of -2, which would be -2 to the 4th minus 5 times -2 squared plus 6. Or you could use synthetic division, which would be -2, and then we set that up. 1, 0, -5, 0, 6. Because I'm skipping an x cubed term and an x term. Any questions? So let's try both. If I have -2 to the 4th, no, that's -2 4 times. So that's going to be positive, right? Correct. So it'll be positive 16, correct? Because 2 times 2 is 4 times 2 is 8 times 2 is 16. Then you're going to do -2 squared, which is positive 4 times -5, so that's -20 plus 6. Did I lose anybody on that? So now you got 16 minus 20 is -4 plus 6 is. Now let's take a look over here and see if we get the same thing. So we got 1, -2, -2, 4, -1, +2, 2, -4. And look at that. So what does this show? It says that either you can evaluate the functions, this is evaluating, right? Or you can use synthetic division. It will both give you the same. Everybody cool with that? So you got options, and depending on what problem you're given, tells you which option you should use. Like, sometimes it'll be easier, I mean, let's think about it. The last problem had negative 5x to the 28th. To use synthetic division, we're gonna need 28 of these. Ain't nobody got that kind of time, right? So I said, hey, instead, let's just evaluate as opposed to trying to do synthetic division on 28 objects. Y'all see what I'm saying? So they're interchangeable. They're interchangeable in that regard. All right, use the factor theorem to determine whether the function f of x, so we got f of x equals negative 2x cubed minus x squared plus 4x plus 3. This is on page 110, real problem 3. And it's determining if x plus 1 is a factor, or x minus 1 is a factor, or are they both factors? That's the question. All right. Now, a factor means that the remainder is what? So if you have a factor when dividing, it means that the remainder is 0, right? As a matter of fact, so the first thing we're going to do is determine the zeros of these two polynomials. So the zero, or rather the zeros of the divisors. So the 0 here will be -1, the 0 here will be positive. Everybody go with that. So now we have to determine whether these two numbers are zeros of this factor, or of the f of x polynomial. But we're about to check and see what happens. So we're going to do synthetic division on both, right? We got -2, -1, 4, 3. So we got -2, bring that down, right? And then multiply, add, and I'm gonna let you do that on your own because I want you to check and make sure that you're getting the same answer as me. We're gonna have to do both. And I want you to see if you can determine whether they're going to be zeros or not. Yeah, multiply -1 by -2, that's going to give me 2. And if I add straight down, it's going to give me 1. And if I multiply by -1, I get 1. If I add straight down, I get 3. If I multiply again, I get 3. If I add straight down, I get 0. So what does that tell you? It's a factor. Yes. Which one? A or B? A is a factor. All right, let's try this one. If I bring -2 down, I get -2, then what? When I multiply -1, or when I multiply 1 by -2, what do I get? -2. Add straight down? -3. -3. Multiply and get? -3. Add? 1. Multiply? 1. Add? 2. Well, 4. Yeah. Well, because you end up with, this is positive 4. Or positive 1. Oh my gosh.
Yeah, I got it.
Oh, yeah. Questions? So is this a factor? No. No, not a factor. Did y'all get it? All right. Potential zeros. For potential zeros, let's say we take a polynomial, and we've got a polynomial f of x is equal to, this is all page 111, we'll go number 4, 3x to the 4th, minus of it, minus 5x cubed plus x squared minus x plus 1. I think yeah, that's right. All right. First thing you have to ask yourself, so when we're talking about potential zeros, then we're saying, hey, there's only a certain amount, there are only a few numbers that make sense for this to be a zero. Okay? And the reason why that is because this polynomial is made up of factors. So for example, the one we did before, where we had x cubed plus 3x squared plus 3x plus 1. This actually is x plus 1 times x plus 1 times x plus 1. Okay? Now, why am I telling you that? Because if you look at the first term is just made up of all these terms combined. Does that make sense? And if you look at the last term is made up of these three terms combined. Does that make sense? So the only way you can have a zero is it has to be some combination of the coefficients of the first and last terms. Y'all see why that has to be the case? Because those first terms have to add up to or multiply up to the first term, and the last terms have to add up to or multiply up to the last term. Like for example, if I gave you three factors, let's say it was 2x plus 1 times x plus 2 times 3x minus 6 or something like that. Okay. Well, the first term in this series would be, well, what is 2x? What would that first term have to be? 6x. How many x's?
Oh, cube.
Cube. Right? Did everybody see that? What about that last term?
-12.
Yeah, -12. No.
No.
Yeah, you're correct. -12. Yeah, or you -12, but do I know what's in the middle? No, I don't know what's in the middle. However, all my factors, which are going to be -1/2 would be a factor, -2 would be a factor, and then you'd actually end up with -2 again as a factor. But all of my factors here are combinations of these numbers. In other words, y'all see that, right? Like for example, this would be -12 over 6 is -2, right? This one those come from. -1/2 is actually 6 over -12, but you get the idea, right? It's a combination of these two. Is it kind of starting to click? So the potential zeros are actually the only way you can have a zero in this polynomial is if you have, write this down, factors of the last term over factors of the first term. And the way I remember it is biblically, last shall be first. That's really how I remember that. Factors of the last one over the factors of the first. So let's take a look and see what does that mean for this problem. Well, what is that last term? 1. So 1. So what are the factors of 1? The factors of the last term, in this case, will be plus or minus 1. That's it. Right? Because those are the only numbers that multiply to give you 1. You can do 1 plus times 1 or -1 times -1, but that's it. That's all you got, right? That's all. What are the factors of the first term? Well, the first term is 3, so there are 2 factors of 3. 1 and 3 itself. Correct? Is everybody following me so far? So then, what are the only potential zeros? The only potential zeros then are the factors of the last term divided by the factors of the first term. So if I take these 2 factors of the last term, which are plus or minus 1, and I divide those by plus or minus 1, I just get plus or minus 1, right? There's nothing else to do. That makes sense? If I take plus or minus 1 and divide by, 3, then that would give me plus or minus 1/3. Any questions on that? So these are the only potential zeros. That's it. 1 plus or minus 1 or plus or minus 1/3. That's it. No plus or minus. right? Because you can always multiply a negative by itself to get you that product. I want to do one more example. So let's say we had f of x was equal to, I don't know, x to the 68th minus 12. Does it really matter what's in the middle? No, so we just deal with it. So what would the potential zeros be? Well,
All the factors of 12, right?
yeah, all factors 12. That'd be it. Because if this number is 1, then I'd be dividing everything by 1, which is just itself, right? So we just plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Now, what if I add on there? What if I then have this 2 here? We'll put a 2 in front. Well, now I need to add on plus or minus 1/2 and plus or minus 3/2. Why are those the only two I need to add in that case?
See the first one. What's the 3 over 2?
These factors over 2.
Oh.
Well, why are those the only ones I need to add?
The other is also lines ones that are equivalent.
Correct. So if I did 2 over 2, I just get this one back. If I did 4 over 2, I just get this one back. If I did 6 over 2, I just get this one back. If I did 12 over 2, I just get this one back. Does that make sense? So the only extras that you actually have to include are when they don't simplify. Any questions? There are no stupid questions, so if there's a question, do that. Okay. Number 5, use the rational zero theorem to find all the zeros of the polynomial function. All right. So we've got f of x is equal to x cubed minus 37x my bad. Thank you. Minus x squared minus 37x minus 35. So, by the way, this last term, we denote that with the letter P. And the first term's coefficient, we denote with the letter Q. So basically, we're looking for the factors of P over the factors of Q.
Well, that makes sense.
But I prefer just the last shall be first. I prefer that one. It just makes more sense to me, but this is the technical definition of the rational zeros function. And it is plus or minus, but you get the idea. All right. So let's start. Factors of P. So we're actually going to find them in this case. Before, all we asked was what were the zeros. Now we're going to find the zeros. The way to find the zeros, you start by determining what are potential zeros. So what are the factors of P, guys? Plus or minus 1, plus or minus 5, plus or minus 7, and plus or minus 35. So then the factors of Q are just 1 and negative 1. So the potential zeros are going to be what? Just the factor. Right? Because if this one is 1, then you just divide everything by 1 and nothing changes. Right? So what we're going to do is we're actually going to check these through synthetic division. So let's try 1. I always try 1 just because I know it's not going to work in this case probably, but we're going to try it anyway. So we got 1, negative 37, and negative 35. Who knows? It might work. So I bring the 1 down, and it's 1 times 1 is 1, it's 0, 1 times 0 is 0. This is the negative 37, and this ends up being negative 37. So I get negative 72. So is this a 0? No, so that didn't work. So what do you think we should try next? Well, if 1 didn't work, maybe negative 1 will work. So we try it. And I'm going to pause right there and let you do that on your own. All right, so let's walk through this. So I bring the 1 down. 1 times negative 1 is? Negative 1. All right, let's get everybody together. We have negative 1 plus negative 1, that's negative
2.
times negative 1 is?
2.
Then you bring that down. Negative 37 plus 2 is?
35.
Then what?
Negative 35 times negative 1 is 35.
Right, and then you add down, you get?
0.
Oh, yay! It worked! Now, me personally, I would actually like to try negative 1 again because if it worked once, it might work twice. Except for the fact that I already know that's not going to happen. And the reason why I know that's not going to happen is I can see kind of like what's coming ahead in terms of this big leap of negative 2. Right? Because negative 2 times 1 isn't going to give me anything close to being negative 35. However, I could try 5, but I think what's even better is if I try 7. I am guessing, guys. I'm not just kind of like, I already know the answer. I actually don't. I'm just guessing. Negative 2, negative 35. So you know, because you're a teacher, you know the answers. Not necessarily. I am just guessing. Bring the 1 down. 1 times 7 is 7. You bring that down. You do it with 5. Oh, look, it worked. 0. And then the last one has to be x plus 5. So of course, negative 5 apparently would also work. Okay, so if I try negative 5, I just want to show that. If I try negative 5, I'd have 1, negative 2, negative 35. That would be 1, negative 5, negative 7, positive 35, and 0. And then my last factor would be x plus 7. So you see, you could have worked it either way. That kind of makes sense? It would work both ways. And so in this case, what are the 3 zeros? Negative 1, negative 5, and
5. I'm 7. 7.
And then the other way, like once again, once you got here, all you have to do is say, oh, x plus 5 equals 0. So the x to the negative 5. So that will work. Or in this case, if you try negative 5 first instead, you say, okay, well that equals 0. The x is equal to negative 7. Either way, remember, finish it off with 0. Don't say plus 5. This is a factor, right? Factor, not the 0. Factors and zeros are opposites, but they mean the same thing. I know that's strange, confusing, but I'm literally trying to say. I guess they don't mean the same thing, but you know. All right, they're representing some of the same stuff. All right, guys, y'all ready? Yep. Let's knock the rest of this out.
Sure.
All right, so number 6. It says solve the equation of real number system. What is it? Okay. All right, so anyway, so I guess what we're just trying to do is find solutions, I guess, to this thing. We got 11x cubed plus 17x squared minus 21x plus 5 equals 0. And so it says solve the equation. So basically, we're trying to find x values that make this true. Well, to find that, we need to find the zeros of this polynomial, which we know how to do. So we'll start with potential zeros. And the potential zeros are, of course, plus or minus 1, plus or minus 5, plus or minus 1 over 11, and plus or minus 5 over 11. Now, I sure hope we don't have to use these last two, but we'll at least start with the first two, or first 2 steps. So I'm going to start with 1 just because 1 is always easy to start with. I have bad feelings not going to work. 11, 17, negative 21, You gotta know I'm going fast, but once again, I'm recording the whole thing, so you can go back and look at it. Or rather, chop it up eventually. All right, so you got 1 times 11 is 11, 1 times 7 is 28, or with 11 plus 17 is 28, and you're with 28. Distance is being 7. Oh, so close. 7. So not quite. All right, let's go. -1. I can see where this is going, and I don't like where it's going. So we got 11, 17, -21, 5. Okay, so we got 11, 1 times 11, so -11. Plus was to be 8, -8, 29. And I don't even have to keep going. I can tell it's not going to work. So on to the next. And literally, this is how you do it. 11, 17, -21, and 5. It's not going to work because I'm going to get too big. I already told you it's too big. You have 11, 11 times 5 is going to be 55. Then you're going to have 72, and then you have 141. Hold on. Cut. Yeah. 0. 1,000.
There's a 0 there.
I missed something. Cut that in half. 30. So 370. 370. Obviously, this ain't gonna work. So 5's too big. So that said, we're gonna have to use one of those fractions. -5 will we can try -5, but it's gonna kind of do the same thing. Don't let it be too big. So let's see, 1 over 11. 1 over 11, we got 11, 17, -21. Hopefully, this will work out nicely for us. So 11, 1 over 11 times 11 is going to be 1. This is 18. We got 18 over 11. Ooh, not looking good. And then we're going to have 21 times 11 over 11, or 231 over 11. Plus 18 over 11. All right. And that's going to give you negative 2. This is why you should do this on a calculator, not your head. -2. 13 over 11. Anyway, I could continue to go, but I can tell this is not going to work out. Because this is not going to come anywhere close to being 5. So I'm going to choose 5 over 11 instead. Hopefully, this will work. I have a funky feeling that it will end up working. Yep, it's going to work. All right, so 17, -21, and 5. We got 11. 11 times 5 over 11, what's going to happen to the 11s? They'll cancel. So you're left with just 5, boom, 5. Then you add straight down 22. Thankfully, this is divisible by 11 too. So that's going to be just 5. 2 times 5 is 10. Boom, -11. -11 here. Then that's going to give you -5 and 0. Yay! So you end up with 11x squared plus 22x minus 11. Now, at this point, you could try to be like, dang, start crying in the corner by yourself. But we're not going to do that. Instead, what we're going to do is we're going to use quadratic formula because I'm not trying this again. Now, we could try 5/11 again if we wanted to. No, wait a minute.
You vote everything else out.
I'm not going to try. So I'm going to use the quadratic formula at this point because it's going to make my life easier. The only reason why I can now use the quadratic formula is because I have a quadratic. Remember, quadratic is x squared, right? So quadratic formula is negative. B plus or minus the square root So b squared minus 4ac all over 2a, and we're going to use that, right? So we're going to do negative 22 plus or minus the square root. Wait a minute. I mean, I guess we can find all the zeros, but we don't really need to. Let's see. B squared is negative 22 squared minus 4 times 11 times 11. Oh, man. Over 2 times 11. Ooh. But you know what? That's why we have calculators, right? Or if you're stubborn like me, you're going to try to do this in your head in like 2 minutes. But you can do negative 22 plus or minus, let's see, 22 squared is going to be, let's see, 11 times 11 times 2 times 2, so 4 times 121, which is going to be 484. Minus 11 times 11, so 484. Yay, this is a big zero, thank God. And then you end up with 22. Are you kidding me? You know, with negative 1, how that negative 1 didn't work?
What's the left supposed to be negative?
Where?
No.
C.
Oh my God. So we would have found it back here. This is why I hate these things. All right, so yeah, that would have been 6. Negative 6. No.
Because C is negative. The quadratic formula, you put 11 times 11, but it should be 11 times negative 11, right?
Oh, thank you. I was about to scream there. I was like, wait, what? Yeah, C is negative 1. So that makes that plus. Ooh, Lord. So that makes that negative 22 plus or minus square root of whatever this is. 8, 6, 1, 9, 9, 68 over 22, which this is not going to be a perfect square root, but it'll be kind of close-ish. 68, square root of that 30 something, so 9, 68 divided by 2, 44, square root of that is 22. Thank God. So this basically is going to be negative 22 plus or minus 22 root 2 over 22. So your final answer is going to be negative 1 plus or minus root 2. Because all 22 is and 5 11s. So the only real rational answer is this one, which I think is all they needed for this particular. All right, we got 3 more problems. I'm going to go ahead and knock those out real quick. So if you do have any questions, just hold on to them. I promise you I'm going to try to answer them, but I want to at least finish what I'm supposed to do first. All right. So the last one says so number 7, we're on page 112. Find the complex zeros with polynomial function. I'm going to write it down. We have the polynomial function f of x equals x cubed minus 13x squared plus 41x minus 45. Okay, so we got this, and we want the complex. Now, here's the deal about complex zeros. Okay, first of all, they come in pairs. Complex numbers, as you'll remember, these are numbers that are in the format a plus bi. In other words, they have a real component and an imaginary component. I'll give you an example. Suppose you have something like x squared minus 4, right? We know that factors down to x plus 2 and x minus 2. We've done it 1,000 times, right? The difference of two squares. The question is, well, what if you had x something like x squared plus 4? Well, remember, the only reason this worked is because you end up with x squared plus 2x minus 2x minus 4, and this stuff in the middle cancels, right? What about this one? Yeah, it's not going to work because you don't have a plus or a minus. So here's what you do instead. What we say is this is going to be x plus 2I and x minus 2I. Why? Well, let's take a look at what happens. X times x is going to be x squared. X times 2I is negative 2xi. 2I times negative 2 times x is going to be negative or positive 2xi. And then 2I times negative 2I is going to be negative 2 or negative 4I squared. Now, does anybody remember what I squared is equal to? Negative 1, right? And so, therefore, this now is into the negative 1. So you've got x squared, these cancel just like before, and now you got negative 4, but now you also got a negative 1 on here. So this gives you x squared plus 4. Everybody cool with that? So guess what? If I have, but these now shows I have two complex zeros. My complex zeros are 2I, or rather plus or minus 2I. 2I and negative 2I. Everybody see that? So those are my two complex zeros. But if you have a zero, like 2I or something like that, or 3 plus 2I or something like that, then its conjugate must also be 0. So its conjugate must also be 0. Why? Because you need the conjugate so that they will cancel. What in the world is a conjugate? I'm glad you asked. If you have 2I, its conjugate is negative 2I. A conjugate is just the negative imaginary part. So if you have 3 plus 2I, its conjugate would be 3 minus 2I. Y'all see that? So if you have one imaginary number, its conjugate must also be a 0 as well. I said all that to get to the actual problem that we have for us. We've got time. I'm going to hit it. I think I've got time to do all three of them, honestly, but. Okay.
I want to ask a dumb question, but what determined the fact that you need to use the constant on the positive side?
Whenever you have something that's like for example, you see the eyes here. Right, because you have, well, it has to have conjugate. Not all polynomials will have complex zeros. Sometimes they'll have all real zeros. This is what we're dealing with so far. All right, so first thing we're going to do is we are going to determine what the zeros are by looking at the potential zeros. Plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 9, and plus or minus 45 itself. Hopefully we won't have to get that far. I have a feeling that 1 will probably work, so I'm going to try it. 41 negative 45. So let's see, 1 times 1 is 1, so negative 12. Negative 12 is negative 12. I'm going to go fast just because. 2. 39. 29. That was his problems there? Okay, that's not going to work. Negative, let's see. 29, so that's not going to work. I don't know. Maybe. I have a feeling it's going to be positive just because of the way that the signs are working out. Because they're alternating, I think the answer is going to be positive. So let's want to try 3 next. 1, 3, negative 10, negative 30, positive 11, 33. So that doesn't work out. Let's try 5. 1 and negative 13. Yeah, literally, this is how you do it. Just overall. Just have to take your time so you can get through. 1, 5, negative 8, negative 40, negative 40, 1, ugh, almost. Oof. 9, 9. Not that promising. I mean, now that we're getting to like getting in now, so negative, but it might be it. It might be it. It might be it. So let's see. 1, 9, negative 4, negative 36, positive 5. Oh,
Nice,
geez,
look at
look
that.
at that.
Wow.
Woo! Thank you. Thank the Lord. All right, now we got x squared minus 4x plus 5, right? Now at this point, we're going to use our good old quadratic formula. As soon as you get the x squared, honestly, the best thing is just plug it into the quadratic formula. So that'll be negative b, which is positive 4, plus or minus the square root of b squared, which is 16, minus 4ac, which would be minus 20, over 2a, which is 2. You can go back and put everything in correctly, make sure to write that out right. All right, so you got 4 plus or minus the square root of negative 4 over 2, or 4 plus or minus 2I over 2. Y'all see where I'm getting that from, right? Because the square root of any negative, you can just get rid of that on I. And the square root of 4 is 2. So then the answers are 1 plus or minus 2. I will divide 2 by anything. So your final answers are, well, the complex zeros are 1 plus 2I and 1 minus. Woo!
All right, guys. Wanted to do just a quick follow up. Okay. So let's see. So for number 7, 7b basically says to find the complex zeros for x cubed plus 125. So it says find complex zeros. So what I would do for this particular problem is I would say, okay, I've got x cubed divided by 125, so I need to find my potential zeros first. So potential zeros are going to be, let's see, well, what are the factors of 125? Well, 125, let's see, it breaks down to 5 times 25, and 5 times 25 breaks into 5 and 5. So the only potential zeros are they're going to be plus or minus 1 and plus or minus 5. And then, of course, plus or minus 25, and then plus or minus 125. So what I'm going to try is I'm going to try negative 5. So if I do negative 5, that'd be 1, 0, 0, see x squared x, and then 125, right? Because this will be our x cubed term, and so on and so forth. Bring that 1 down, negative 5, they add straight down. This will be positive 25, 25, negative 125, and then 0. Yay! And now we're going to use our quadratic formula, which is what we're going to use most of the time when finding complex zeros. So remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to take that negative b, so negative 5 plus or minus the square root of negative 5 squared plus 4 times 1 times 25, and then all over 2 times positive 1. So that's going to give you positive 5 plus or minus the square root of 25, positive 25, plus 100 all over 2. So that's going to give you, let's see, minus 4ac. So be minus 100. So with 5 plus or minus the square root of negative 75 over 2, which gives you 5 plus or minus 5i root 3 over 2. And these are your two complex zeros. Okay. All right. And the way I did that, by the way, guys, is I did negative 75. I know it's going to be I root 75. And I took the square root of 75, broke it down into 25 times 3. What's the square root of 25? Well, it's just 5. So 5 root 3. And so that's how I end up with 5i root 3. For 7c, I've got f of x equals x to the 4th plus 12 x squared plus 11. So what I could do here is I could say, hey, this is x to the 4th, and x squared is just half that, and there's no term on the last term. I could treat this like a quadratic. Excuse me. I could say, okay, what are two numbers multiplied to give me positive 11, but add to give me 12? Those will be x squared plus 1 and x squared plus 11. Right? And so since I've got those, what I'm going to do is I'm going to say, okay, I can do, see, x squared plus 1. I know that's going to break down because remember, x squared minus 1, that'd be x plus 1 and x minus 1. Or x squared minus 16, we knew that'd be x plus 4 and x minus 4. Well, x squared plus 16, remember we talked about this, it'd be x plus 4i instead and x minus 4i. So what I'm going to do is I'm going to say, okay, well, this would be x plus 1i, or just I, and x minus 1i, or just I. And then I have to take the square root of 11, just like we took the square root of 16 to get 4. So I'm going to do x plus root 11i, because it's irrational, and x minus root 11i, which is also irrational. And those would be the complex factors, but the complex zeros would be I, negative I, root 11i, and negative root 11i. Conversely, the zeros here would have, well, where are the zeros from up here? All right, guys, I realized that I actually did not answer the question that 8 was asking. All 8 was asking. Ooh, man. Okay, so all 8 was actually asking was to find the other zeros. That's it. So, like, for example, his degree was 4, and the zeros were I and 14 plus I. I was actually trying to find the polynomial. I didn't even ask for that. It was just asking for the remaining zeros, which would obviously be negative I and 14 minus I. And so for part B, with degree 5 is zeros 5, 2i, 3 minus I, then it's negative 2i, and then 3 plus I. Remember, the only thing that changes there is the sign on your complex, on your imaginary term. So that's all 8 was asking for. So yeah, I feel kind of foolish, but that is what it is. All right, bye. And then lastly, for number 9, we've got f of x is equal to x cubed minus 9x squared plus 4x minus 36. And we're given that one of the zeros is equal to 2i. So once again, we're going to walk through this. We're going to end up with, let's see, 2i. We've got 1, negative 9, 4, negative 36. So I'm just going to use it. We got 1, let's see, 1 times 2i is 2i. That'd be -9 plus 2i. So note that's all one number. 2i times 2i, 2i times 2i is going to be 4 times, let's see, 4 times -1, because I squared is -1, so -4. So if I multiply this number 2i by this number 2i here, then I'm going to get -4. And then if I multiply, because what you're doing is you're going to multiply -2i times -9 plus 2i. That's going to give you positive 18i minus, not -4, but +4, right? Ooh, this is positive 2i. Never mind. Anyway, all right, let me start all over again. So now when you multiply 2i times -9 plus 2i, that's going to give you -18i, but then it's going to be plus 4i squared, which I squared is -1, so it's really going to be -4. So right here goes -18i minus 4. So 4 minus 4, those cancel, you're just left with -18i. -18i times 2i is going to be positive 36. So you end up with 0. And the way that's positive 36 is you have 2i times -18i. You end up with -36i squared, which once again, I squared is -31. So that negative turns into a positive. And so now you're left with these. You got 1, you got the complex number -9 plus 2i and -18i. But we know that if this is a 0, its conjugate -2i is also a 0. So we're going to use -2i for that part. And we're going to cancel some stuff. So 1, -2i, the -2i's cancel, you with -18, you go with positive 18i. When you multiply, and you get 0. So the last one is x minus 9. So the remaining zeros, all the zeros would be 2i, -2i, and because this last piece is x minus 9, if that set that equals 0, the last 0 is positive 9. Questions? All right, guys. Have a good one.